So I've known Michael Howard for a few years now. Michael is the principal cybersecurity architect over at Microsoft. We are very fortunate that he is located here in Austin because I don't know if he would have come if it wasn't. But Michael's an awesome, awesome guy. I've seen him present many, many times, and I hope you guys enjoy him. Thank you.
Thank you very much, Josh. Appreciate it. I would actually tell you need to have a shave, but I think I do too. So actually, it's kind of funny. Whenever I give like talk at events like this, I'm always kind of nervous. I don't mind. It's not because of the public speaking aspect. It's because normally, whenever I get up here, there's a little piece of paper waiting for me on my laptop that's folded over. There's an old game that we used to play when I first started at Microsoft, where you get up on a presentation, there's a piece of paper waiting for you, folded over, and you can't open the paper until you introduce yourself. Then the moment you introduce yourself, you open the paper, and there's 5 words in there. And those 5 words you've got to add to your presentation while you're presenting. So you got this like background thread running while you're presenting, trying to work out how you're going to add these 5 words. And they're not normal words either. One I had things like technicolored yawn, Tyrannosaurus Rex, a lot of other words as well that I don't really want to repeat too much. But anyway, thankfully, there's no note on. We should start that. We should actually just. We should just start it just for a giggle. Anyway, so as Josh said, my name's Michael Howard. There's my email address. Please feel free to email me if you have any questions whatsoever. I've been at Microsoft now for 20 years. Actually, I hit the 20-year mark in June this year. I've always been involved in security, but my career's kind of broken in half, really. Half the career is security sort of features, access control lists, permissions, privileges, crypto firewalls, all the sort of good hearty, Kerberos authentication, all that sort of good stuff. Then about midway through my career, it kind of changed quite a bit to focus on security as in threats to software, which is a significant difference from just access control lists and permissions and privileges and firewalls and crypto and stuff. In fact, it really applies itself quite differently in that if you understand the threats to systems, then you know how to apply these different techniques and technologies to mitigate those threats. And so it's a different way of thinking about things. I've worked on the Microsoft SDL since its inception. Me and my old boss, Steve Lipner, he and I were sort of got things going, as it were, back in the day. And so I've been working on the SDL since then. It's updated every single year, and I've always had some hand in working on the SDL. My main area of focus was on the unmanaged native C and C++ stuff, so things like NX, ASLR, GS, band APIs, those kinds of things that go into the compiler and into the operating system. That was my main area that I worked on. And now I work directly with customers. Basically, we had a lot of requests from customers working on, they want to understand more about how to apply security methods to their systems. The cool thing is more customers that are coming to the security community to ask for help, rather than us going to them and sort of keep telling them that the sky is falling. So we found more customers coming to us now to ask for help and getting a lot of sort of pragmatic guidance on how to basically up their game, which is really the title of this session. Along the way, I've written a couple of books. Probably the most well-known is Writing Secure Code that I wrote with David LeBlanc. People have asked us if we're doing a 3rd edition of Writing Secure Code. We don't know. We may. But the joke right now is any of the proceeds will go to the divorce lawyers. So we're not sure if we actually will actually do a 3rd edition or not. So anyway, before I get started, there's a bit of a disclaimer. This is a lot of things that I've learned over the last few years working with customers. But many of the observations are very broad. I will be honest, they are very, very broad. I'm not going to give you, specifics about a customer. I mean, that would obviously be a stupid thing to do. An agenda of sorts. I'm not going to go through it because I'm going to go through everything that I'm going to cover. But basically, these are things that I've heard and learned over the last year because, I've worked at Microsoft for 20 years, and I've worked in Microsoft product groups for 19 years. I'm used to working on Windows. I've worked on Windows since NT 3.1. I mean, I'm used to working on these big projects, and it's very different, when you go and work with a bank. or you go and work with a government in Asia. It's very, very different. I'm sure you all know that, but it's different. There's things that you can do in an organization like Microsoft that you just can't do if you're a government organization. And so it's really kind of been a bit of an eye-opener actually for me over the last year or so. So the first one is, and we all know this, but security expertise is absolutely atrociously low. I'm kind of blown away at how low it is. Now, I wouldn't be too concerned, except for the fact that we have this massive connectivity. We know this. We have this massive connectivity. And with that, this hyper-connectivity, you've got plenty of people out there who are willing to take down your systems. It wouldn't be so bad if these were just isolated systems. I was looking at some code that I wrote 20 years ago, and the code is absolutely secure. The code quality is lousy, but the code is absolutely secure because it was never designed to be networked. So it didn't really matter. The worst that you could ever do was actually have a memory corruption that affected yourself. You could basically attack yourself, which is not exactly very interesting. But when it comes to attack, if that system was networked, it would be a completely different ball of wax. So we really need to focus a great deal on raising that security bar above 0, because that's where it's at. It's 0. And unfortunately, it can't be 0. And the schools are not doing it. The schools are not teaching people. They're just not. They refuse to do it. I'm not saying they actually probably don't refuse to do it, but they don't see a need to do it. I interviewed a very smart woman from a very prestigious university. She was a PhD student, and she was applying for a job at Microsoft. And she'd built this like Wi-Fi collaborative thingamajig. And I'm like, so what are the security implications of this thing that you designed? Don't know. What are the privacy implications of it? Don't know. Well, okay, let's throttle back a little bit more. What about the reliability aspects of it? Don't know, don't care. So, well, the problem is, in the real world, you have to care. You have to care about security, privacy, reliability, and all these other things. You have to care. And so we have this sort of very insular, these very insular students coming out who have no concept of what it means to build secure systems. And unfortunately, you need to have some knowledge today. As I mentioned a little bit later on, everyone doesn't need to be a security expert. You at least have to have a baseline level of knowledge that's not 0. To at least understand some of the basics of what can happen and what simple mistakes can be made. Every organization I've been to, almost every organization, has had these massive security efforts around training. And every single one has failed. They've spent millions of dollars or hundreds of thousands of dollars on these big security training events, and they've not worked. So they spent all this money and nobody came. And the numbers of the number of attendees has been woefully low. And the problem with that, and the reason for that, is because it's so big and it's so overwhelming that people just don't want to go because they're really afraid that they can't retain all this information. And frankly, they get so much information that they get complete overload, and they can't really apply it after that. And then word spreads, people are like, don't go to security training. Whatever you do, don't go to security training. It'll be the worst 6 hours of your life. Just don't go. You'll never get that time back. You may as well go and play Halo or something. So what we found that does work, though, is to have very, very small and very, very pointed training sessions that are like 30 minutes to an hour long. So for example, if you're building stuff using Agile methods, and in your next sprint you're going to be doing a whole bunch of database stuff, right? Make sure everyone understands SQL injection issues. That's it. They don't need to know the whys and wherefores of memory corruption issues in the Linux kernel. They don't need to know about that. Now, there may be some couple of sick puppies who do like to know about that kind of stuff, but basically, all they need to know about is database security, SQL injection vulnerabilities, how we're going to protect the data in the database. That's all they need to know. Next sprint, it may change. That's fine. Then you go through another 35, 60 minutes of training. You don't need to boil the ocean every single time. The beauty of this, 1, it's very, very approachable. 2, you know what? It's actually enjoyable. People actually enjoy doing it. 3, it doesn't cost a lot of money. 4, I'm sure there's a 4th reason. But basically, don't underestimate the value. This is quite serious here. Don't underestimate the value of Josh sitting in front of a PowerPoint presentation recording, well, someone other than Josh recording it, but someone recording, like going through the slide deck, saying, you know, this is a SQL injection vulnerability, this is why they're bad, here's an example of how people got whacked in the past, and here's how we're going to make sure we don't have these problems moving forward. End of presentation. Oh, and here's my email address if you have any questions. Here's a tool that you run to make sure you don't have these issues. 35 minutes, perhaps? 45 minutes? It's not rocket science. The other problem that we see a lot is staff retention, where people come to the organization, you train them up on security, they're, wow, this security stuff's kind of cool. I now have security credentials, I'm going to now go and get a job somewhere else. So one thing that Jeremiah and I were speaking about this yesterday, and we both kind of agreed on this idea of perhaps, I mean, getting people to a baseline level of expertise should be everyone's job, absolutely. However, there'll be a population of people who really want to understand security. You may want to make sure they've been employed for a little bit, like 3 or 4 years, before you start turning them into security pros. Because they probably will leave the organization. Many people will, but if they have some allegiance to the organization, you're probably okay. But staff turnover is definitely a problem. I made a little comment at the bottom here that 24 deadly sins is greater than Write Secure Code. Write Secure Code is really an encyclopedia. But 24 deadly sins is like, okay, if you're building database stuff, read these 3 chapters. You're doing web stuff, read these 4 chapters. You're writing C and C++ code, read these 5 chapters. That's it. It's very, very pointed, very, very specific, really low barrier of entry. And that's why, even though the book is a third the size of Writing Secure Code, I actually think it's a much better book just because of that. So next one is people are not learning from their mistakes. People are just not learning from their mistakes. I see companies who have got bug databases, those that even have decent bug databases, they're not learning from those things. Are there any trends? Do we see any trends in there? Do we see people making the same mistake time and time and time again? In many cases, they're just not even storing data. I've seen people who, there's a bug found, and it gets lost. No one even bothers entering the information. I mean, at Microsoft, we enter, you know, if someone sneezes, it's put in the bug database. I mean, everything is put in the bug database. Some of it may be junk and of no use, but we can still detect trends, which is really important. So, you know, one thing I've told, I would say 50% of the customers I work with is you need to get a handle on your bugs. You need to know what bugs you're creating so that you can learn from those to make sure you don't keep making the same mistakes. Also, poor categorization. I mean, at Microsoft, we're really, really pedantic about how you mark security bugs. There's like 3 distinct fields that you fill in for every bug if it's a security bug. That helps us triage the bugs later. It helps them bubble to the top when we're doing analysis of bugs. And the beauty of it is you do it like just once, right? You set the bug categories up front. We define them in the SDL. You can get them from the SDL website. You put those in there. When people enter the bugs, they put the security information in there. And it's done just once with the bug, unless someone made a mistake. But basically, it really helps you learn trends and security trends over time. To me, a bug is a massive learning experience. And if you don't do that, if you don't learn from your bugs, you will continue to make the same mistakes time and time and time again. So here's a really good example at Microsoft. So we're quite happy banning functionality. We're quite happy to ban APIs. If they're shown to be very insecure over time, we'll ban APIs for new code. And so I was doing a root cause analysis of all these bugs, and I found that there was a trend where there were some critical vulnerabilities that we were issuing patches for, calling in C code using memcopy. We found 7 of these things over a period of 3 years. At that point, the threshold had been exceeded, and we just banned memcopy from that point forward. We changed our education. We went into the Visual Studio team to add new rules to their static analysis tools. We did a whole bunch of stuff, and we had a good replacement too. We did all these things to make sure that we don't keep making those same mistakes time and time and time again. I only have one word. If you got bugs, I only have one word for you, and that is root cause analysis. You have got to do root cause analysis. If you're issuing if you are issuing patches to customers, you need to understand why you're issuing those patches. What went wrong? Why did we miss them? Why did we miss that bug? Was it a coding issue? Was it a design issue? Why did our analysis tools not find it? Why did our code review not find it? Why did our fuzz testing not find it? Why did our peer code review not find it? What went wrong? It's not incriminating. As long as the whole organization understands that this is a learning experience, not pointing fingers, it's good. I was at a company a few weeks ago where they said, we will never do this. I'm like, why is that? They said, because someone will get blamed. I said, well, okay. He without sin cast the first stone. You know, it's the same thing. We all mess up every day of our lives. Who has never created a bug in their lives? Oh, come on, anyone who sticks their hand up is lying, and you know it.
Only if they've written no code.
Well, if you've written no code, then you've messed up elsewhere. In my opinion, writing code is just a way of venting your errors. You need an escape hatch somewhere. I do it, it's my code. Problem is everyone else has to suffer with it. But so the point here is you've got to learn from your bugs. You've got to learn from your mistakes so you don't keep making the same mistakes time and time and time again. Now, I'm not saying do that for every single bug, but if you see a pattern, then you start to say, okay, what's going wrong here? Now, you'll never see a pattern if you're not logging the data. You will never see a pattern. I mean, I hate to say this because you're going to think I'm like a really sick puppy, but I love reviewing bugs. I love reviewing bugs because I know that if I spot a trend, I know that I can go and influence the SDL, which will influence Microsoft products, et cetera, et cetera, et cetera. It's really important that everyone learns from their mistakes. I'm not talking to bugs and all these kinds of things. So all bugs are not created equal. And in fact, as security practitioners, I would argue that we're doing ourselves a huge disservice here. As security practitioners, many security practitioners, not all, but I was definitely like this for a long time, basically see every bug as catastrophic. It doesn't matter how tiny it is or how it's the end of the world. And if you don't fix that, your product will never be secure ever, and you can't ship. The problem with that is twofold. One, you're probably wrong in many cases. Two, you're going to end up burning bridges. As security people, we need to build bridges with the rest of the developer community. When I used to go to the Windows War Room meetings, it was every day. We meet in the morning. We go over which where the really, really hard decisions are made every single day for Windows. And if I ever turned up, I was affectionately referred to as the angel of death because I never went to Windows War with good news. But the thing is, when I went to Windows War, people knew I was there for a really valid reason. I wasn't there just to make people's lives miserable. I was there because I had something that had to be worked on. Because I built up the credibility by not going to Windows War with frivolous bugs. I went to Windows War with something really serious that had to be addressed, or at least everyone had to be notified about. So all bugs are not created equal. It's really important to understand this. A remote code execution on an unauthenticated UDP endpoint is critical. The same code behind an admin-only authenticated local name pipe is not as critical. I'm not saying don't fix it, but you may not stop the product from being shipped because of that, because the attacker can only be an admin physically at the box versus a spotty-nosed kid in Elbonia. There's a big difference between those two. A lot of that boils down to understanding your attack surface, but that's a discussion for another day. So I believe this wholeheartedly. A security amateur can tell you how to secure something. A security professional knows when you don't have to. That to me is the delineation between amateurs and pros in this field. Unfortunately, I think that last bullet point comes from experience, and sometimes the school of hard knocks. We need more threat models. Every single customer I have worked with over the last year, where we built threat models in conjunction with them, we have found critical security design problems, critical design issues, 100% of the time. In fact, I went to one customer once and they said, we know we have a design issue. Let's see if your threat modeling process will find it. We found that design issue in 20 minutes and 3 other ones they didn't know about. It took about 2 hours all up. We need more threat models. Because we, as an industry, we focus a lot on the code. We don't necessarily focus on the design. I mean, I see jobs for developers all the time, job opportunities for developers. I see very few for good designers. We need more good design, fundamental design. And the threat model can help uncover a lot of those design issues very early on. I was working at a customer just recently, and this is actually taken from one of the recommendations I made. Just in case you can't read it, this is just how I write documents. So to be totally candid, I would not bother fixing the coding issues for the moment. The company should focus on the lack of server authentication and exposed on-the-wire data. No amount of bug fixing will compensate for the insecure design. They had all these security bugs. I don't care, like coding issues. I don't care. They've got this massive design problem. They're sending very sensitive data to somewhere over an unencrypted channel. So sensitive data is going to a remote box somewhere. They don't know what it is because there's no server authentication. No problems, no clue whatsoever. They have no clue who they're communicating with. The original fix they were going to do was to use encryption of the channel, but still no server authentication. So they're going to have a secret conversation with something. Don't know what, but it's secret. All right, next thing I hear a lot, customers ask me, so define secure. What does secure actually mean? It doesn't mean perfection. I'll start off with that one. It doesn't mean perfection at all. So the sort of description that seems to work really well with customers, and they kind of understand it, and it's not sort of too computer science-y, is a secure system is a system that does what it's supposed to do and nothing else. So for example, you got a system that does, I don't know, payroll, right? So I can look up my statistics on payroll. If there's a SQL injection vulnerability and I can look at everybody's payroll information, I'm sure the system was never intended to do that, unless I was authenticated to do so, right? Like someone in HR or in the payroll department. So that's an example of the system doing more than it's supposed to do. And this tends to gravitate pretty well with most customers, that definition. What I will say is some people think that a secure system is a perfect system. That's just not necessarily true. It's not, because there will be mistakes made. One thing I've said to customers many, many times is you have to assume there will be failure. There will be failure. It's just the nature of things. If you don't think there's going to be failure, then you're living somewhere else. Because on the planet I live on, there is failure all the time. So, but what they want to do is they want to strive for this perfection, but they'll never get that perfection. And so they don't think their systems are going to be secure. You can be secure enough. This is a really important point. So don't let good enough, don't let perfection get in the way of secure enough. It's all about managing risk, getting risk down to a level of acceptability. That's all it really is. Sometimes you have to fail fast, and you've definitely got to fail closed. Fail fast. That's why if you look at all the memory corruption mitigations that we started in Windows XP, Windows Vista, Windows 7, now really up the game in Windows 8, which, by the way, I have a Microsoft Surface with my name written on it, and I'm heading out of here to go and pick it up. When I realized what the date was, we were releasing the Surfaces, and I realized, I'm going to be doing a keynote the morning I'm supposed to be picking up my Surface. But I'm glad to be here. I'm glad to be here. I just realized what I said. But if you look at the memory corruption defenses that we've had in Windows over the last few years, it's all about fail fast. It's all about fail fast. It's all like GS, like stack-based buffer overrun detection. We detect stack-based buffer overrun, bang, kill the process dead. Safe exception handling. Something corrupts an exception handler address, bang, kill the process dead. You try to dereference some memory because it's in a different location because of randomization, bang, kill the process. Try to run code, try to run data as code, bang, we kill the process. Why? It's memory corruption. You don't know what state the system's in. If you've got like a low-level embedded system written in C++, you got memory corruption and you want to keep on going, really? You really want to keep on going? You have no clue whatsoever what the state of the system is, and you want to keep on trucking. Really? I think that's dangerous. Now, what's been really interesting over the last few years, I've spoken to a bunch of people who build embedded systems that monitor nuclear power stations, things like that. It's a really hard problem for these guys because they have to think about, okay, if the system crashes, then what? So they got rollover mechanisms, backup mechanisms, and so on. But they would much rather fail fast and fail safely rather than eventually fail with some really weird and potentially disastrous outcome. Failing sucks. It does suck. Failing closed so that someone doesn't get the data, it sucks. However, that sucks a heck of a lot less than running malicious software or exposing sensitive data. In the absolute worst case scenario, if a system fails closed because of incorrectly, the worst you're going to get probably is an irate customer on the phone complaining. But at least you can find out what the problem is and fix it. That's a heck of a lot better than a customer on the phone saying, that system that we deployed of yours, we've just leaked all of our credit card information. At that point, you can't control that situation. At least the former you can control. So I'm a big believer failing closed and fail-stop situations. So the balance that I've also noticed is the balance with our customers is shifting from security to privacy. You look at all these defenses that people tout, NX, ASLR, safe exception handling, stack-based buffer overrun detection, blah, 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 blah. They're all incredibly powerful, incredibly useful. But they're really there as security defenses. They're not necessarily there to stop someone swiping the data. You look at sandboxes. A lot of sandboxes are all about isolating an application from corrupting the OS. They're not about preventing disclosure of data. They're all about preventing, basically, integrity of the system, protecting the integrity of the system. It's a classic sort of Bieber integrity model versus the Bell-LaPadula disclosure model. So we're seeing more and more of a concern move to privacy. The good news is if you talk about privacy to CISOs and CSOs, they get that. Security is still kind of this amorphous thing that's very hard to measure. Privacy is a lot more easy to measure. So yeah, it's all about protecting the data. It's the data, stupid. So if any of you, I'm actually surprised, how many people know who this guy is? Yeah, it's James Carville. I love Carville because he's just funny, especially when he gets really wound up. But so basically when Clinton won his second term, it was generally attributed to Carville because he came up with this thing where he said, it's the economy, stupid. And that became kind of like the mantra. So he's generally considered with helping Clinton get his second term. Although I must say, I think he looks a lot like Mr. Bigglesworth from Austin Powers. Tell me those two were not separated at birth. I swear he's the father of Dr. Evil's cat. I sent these emails out to a bunch of friends, to a bunch of colleagues last night, and two of the guys are like, who's the cat? And I explain. Another guy says, you know what? You're dead right. He looks just like Mr. Bigglesworth. Yeah, without the glasses. Anyway, so the point is, if you can talk about security in terms of privacy, because there is an overlap. It's not 100% overlap. This is something else that I've kind of learned as well, is that you can have security without privacy, but you can't have privacy without security. So if you're striving for both, that doesn't. What I'm trying to say here is, if you're like security people, you haven't lost your job, right? Because you can't have privacy without security. You need to have essentially both. One thing I will point out, though, is that privacy is quite a different field than security, quite different. A lot of people that I deal with inside of Microsoft who deal with privacy, a lot of them have got legal backgrounds, international privacy laws. You need to understand some of these things. But you can start with some just basic things like just protecting the data. That's what it's all about. It's all about just protecting the data from disclosure. Which leads me quite nicely to SQL injection. Every single customer I've spoken to, seen in the last 18 months or so, they've all had SQL injection vulnerabilities of varying degrees of badness. But they've all had them. And I would say 50% of them didn't really know they had them, meaning they didn't even know what they were. Now, what they said, which is what I'm sure you guys heard exactly the same thing, is, well, all our functional tests just work fine. Well, of course they work fine. Because the code, even if it's insecure, it still works correctly. When it's under normal conditions, it works absolutely correctly. So, but then the problem is, if you look at this, the definition I had for a secure system, the system is doing more than it's supposed to be able to do, which is return any data from the database in many cases. I've actually heard from 2 customers, well, we are writing our code in C#, Java, PHP, Perl, Python, Ruby, you name it, because our developers told us that moving from C, C++ to these safe languages means we're never going to have security vulnerabilities. So is that right? And what planet are they from, exactly? Because of the planet I live on, there are fundamental skills that you need to understand that transcend all programming languages. And I've been beating this drum for probably 15 years at Microsoft, which is, never trust input. It's that simple. All data is evil until proven otherwise. It really is. Because if developers just get that into their heads, I even made a joke once. I used to give the security boot camp training at Microsoft. It's 4 hours long. It's not to turn you into a security expert. It's to give you the basics of what you know, or you should know, and also to make you aware of what you don't know. But halfway through, I do all the design stuff and threat modeling stuff and fluffy stuff up front. Then finally I get to the enjoyable part, which is all the coding bugs. But the very first slide is basically, this is all an input trust problem. That's all it is. Buffer overruns, SQL injection, cross-site scripting, cross-site request forgery, XPath injection, XML injection, LDAP injection. They're all input trust issues. That's all they are. You're taking some junk off the internet and assuming that it's correct and then doing something potentially sensitive with it. Really? So the joke I would always say, like halfway through this presentation was, if you guys promise me that you'll never trust input coming into your system, we can stop right now and I'll just go and play Xbox for the next 2 hours. Of course, no one would ever make that promise, although the urge was there to make that promise. But that's the problem. We still see that. People are just taking input and they're just blindly trusting it. And so the canonical example I give to people, and I show this code all the time, is the code that led to Slammer, which is the bug in SQL Server. There you can see the receive from, right, which is a UDP read off the internet. The third argument is a buffer. That buffer is toxic waste. You do not know what is in that buffer. You have no stinking clue what's in that buffer. No clue. And then all of a sudden they go and do an sprintf, right, which is essentially a string copy, without knowing what's in that buffer. And that's what led to Slammer. And so you need to identify in your code all these entry points and what the data is. Maybe an array, it may be a variable, it could be whatever, right? But there's a point where it comes straight from some untrusted source, and it is completely toxic, totally toxic. You need to verify that is completely correct. Do some validation of that. Could be a regular expression, could be length constraint, whatever. No one knows what cross-site request forgeries are. They just don't. And no, I threw that in for a joke. No one's actually said to me, does penicillin fix it? But basically, no one knows what they are. Yeah?
Michael, do you think developers should know about CSRF? That's one risk that I think the framework should handle that developers really should be.
That's a really good point. And that is, should developers know about it? Because that's something the framework should handle. And I completely agree with the latter point. I mean, ASP.NET, we have the defense in there by default. I was actually working in China earlier this year, and they had actually added their own defense. And it was broken. It was a wrong defense. They were generating sequential numbers. They were unique, but they weren't random. So which speaks to the point, right? It's like that should be in the stinking framework. But they knew just enough about CSRF to go and mess it up. So I think developers should know about it, because they say, why is this? Because the last thing I want is someone saying, why are you generating these random numbers here? I'm going to turn that off. That's going to slow things down. So I hear this all the time. How many of you heard this? The system is only as secure as the weakest link. It's wrong. It's completely wrong. We've said it so many times that people have believed it. It's a lie that's been perpetuated. It's like politicians. They tell these lies, and eventually people just believe them. You keep saying it over and over and over again, and it eventually becomes the truth. We have systems like this, right? Got some hacker, gets into some system, port 80 is wide open, web app, SQL injection vulnerabilities, cross-site scripting vulnerabilities. insecure configuration, back into the back-end database, blah, 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 right? The whole 9 yards. The whole thing is completely messed up. However, you can add encryption. Don't get me wrong, I'm not saying just go and build any old junk. You know, do write good SQL database access code, and do write good web app code, and do have secure configuration, and do have good permissions on sensitive objects in the OS. Absolutely. But the question I ask customers all the time is, okay, well, let's assume there's vulnerabilities all along the way. The attacker is now in your database. Can he get the data? Yes. Okay, let's assume the attacker's got the data. Can the attacker actually make use of that data? Well, if it's correctly encrypted, using appropriate algorithms with appropriate key management and appropriate key protections, then no. The attacker can't get the data. I mean, obviously the best thing is to not have any sensitive data in there at all, but you know, some systems have to have sensitive data. And so you can add extra layers of defense. And as a side note, never use the term defense in depth. All CSOs see, when you say defense in depth, all they see is wasting more money. That's all they see. So I went to a thesaurus, and what you should use is use compensating controls or mitigations. They have no clue what that is. But it sounds like, you know, especially the first one, compensating controls. My wife's my compensating control. I can promise you that. But seriously, in fact, if you look at the old literature from the 1970s, so my old boss, Steve Lipner, his name is on the original Orange book and on the Red book. You remember the old Rainbow series? His name is in those books. He's not sure if that's a good thing or a bad thing, but his name is in those books. And in fact, if you go into his office, he's actually got a stack in his office of the whole Rainbow series. But if you actually look back in the literature of that day, they talk about compensating controls. Just compensating for failure elsewhere. Because as I mentioned before, the system will fail. So what are your compensating controls? Crypto and SSL TLS are still a massive mystery to many, many people. They really are. People are messing this up left and right. I mean, at least I've only seen one customer like sort of create their own crypto, like their own algorithm. The rest were all like calling crypto libraries. There's a lot of mistakes being made. And one of the biggest mistakes is when people have like a socket connection out to some other machine. They do like OpenSSL to do SSL over that. So they're actually putting SSL over some other specialized socket. The problem is you need to do a lot of work to make sure that the connection is secure. Like for example, chaining up to a trusted root, like not a self-signed root. A self-signed root being a root that you've just created for your own purposes, unless of course you're testing. But things like date validity, key usage, and no one is doing revocation checking. No one is doing revocation checking. And admittedly, it's a hard problem to solve, right? Because earlier on, I said about fail fast and fail enclosed. So what happens if you want to go and check someone's certificate and you can't reach the OCSP server or you can't get the certificate revocation list? What do? So it's a hard problem. So what do? Do you allow the person access? Well, the attacker in me says, well, as an attacker, what I'm going to do is I'm going to knock out the OCSP server so you can't check if the certificate's been revoked or not. Then I'm going to make my request because you can't get to the OCSP server. So when I worked on IS5 was one of the first web servers where we actually had client authentication over SSL with revocation checking. It was a really hard decision. So what do? So if a client authenticates to an IS5 server with a client certificate, but we can't check the revocation status of that certificate, what do? So the decision was made, and the default was made to fail closed. So basically, we return this error that the user will never understand. And there's a good reason for that. It just looks like a normal forbidden status code, but we log all the information in the event log. So at least the admin can work out what went wrong. But we don't tell the user, in this case the attacker, that their certificate has been revoked. We don't tell them that on purpose, and we fail closed, which in my opinion is exactly the right thing to do. Because in the worst case scenario, someone's is going to have a genuine certificate that's not been revoked, but for some reason we can't get to the OCSP server or verify the CRIL and the user will be, can't get the job done. But at least you can see what's going on. There's obviously a problem in the system at that point. I still see a lot of embedded keys. And the last one, everybody does this. Okay, how many people in this room have written some kind of crypto code at some point in their lives? I don't mean create their own crypto algorithms. I mean just call the crypto library. How many of you have never actually put in the code the name of the algorithm, like create a new AES object, or create a new MD5 object, or a SHA-256 object? How many of you have never, how many of you have never written code that way? Yeah, exactly. And I'm not going to put my hand up either, because everyone does that. The problem with that is if the algorithm's busted, your application's busted. So these people, I still see code today using MD5. MD5 is officially broken. You should never use MD5 at all. No, the only excuse is if there's some backward compatibility with like an IETF, some internet standard. A really good example is digest authentication. In their infinite wisdom, it is hard-coded to use MD5, which is just ridiculous. It should be crypto-agile. Like SSL is crypto-agile, right? You can actually say, I'm only going to allow these algorithms. And the two sides will negotiate to the appropriate algorithm. So basically, if you say, I'm only going to allow algorithms A, B, and C, and the server does C, D, E, and F, you're going to negotiate to C. The only downside is if you do A, B, C, because your security policy says, I only do A, B, and C, and the server only does D, E, and F, there's no SSL. Fails closed. There's no negotiation at that point. And so one thing that we're doing at Microsoft now is I'm not telling customers to do that. I'm making customers aware of this, but not telling them to do it just yet. But what we're doing at Microsoft is telling all new developers who are developing new code using crypto is to use the classic class factory sort of model or pattern. In other words, what you do is you pass in the name of the algorithm you want at runtime from a configuration source. Or it may even come from the data structure itself. So when you're encrypting something, you like build, say, an XML payload that would have the algorithm information, then the actual payload. So the data is actually self-describing. So that way I can always read the data. I can read out, it's AES, 128-bit, cipher block chaining, PKCS7 padding, and has an initialization vector of this, so on and so forth. That way I can reconstruct the appropriate object at runtime to read that data. So I can always read old data. Then what you can do is you have a configuration file that says I only support these 5 algorithms. So you can always write back in a more secure algorithm. You can always read even old ones, but you'll always write out new algorithms if you need to. It works really, really well. In fact, one of the reasons why we did CNG in Windows Vista and later to replace Crypto API was one thing we added was the ability to use names for algorithms, which helps support crypto agility a lot better than Crypto API does. So we need to see less hard-coded algorithms and more generating the objects on the fly at runtime. It's way better, because there's a lot of crypto research going on. And we'll see more and more stuff getting busted. And there's another good reason, and I realize I'm really getting close on time, but I've got to tell you this one. And that is that historically the impediment about breaking crypto is the cost of the hardware. Well, you can rent the hardware. It's called the cloud. You don't need to buy it. You just rent it. And so the rules have all changed. So busting crypto is actually a lot easier now because someone else has done all the capital expenditure for you. You just rent the stuff for a couple of days. Rent a machine that's got 4 NVIDIA video cards in there, right? So now you're parallelizing all the key analysis in video hardware, right? All the C compilers today all have support for the likes of CUDA and OpenCL, right? They can do all this stuff. You can offload all that work into hardware. If you've got a video card that's doing nothing but doing crypto primitives, because you're making it do that, we can run them all. You've got 4 video cards in a box with 200, I'm just picking numbers out here, but 256 parallel streams. You can take a key stream, a key space, and you can completely parallelize the analysis of that key stream to find the keys. The rules have all changed. That's why we're pushing more and more of this crypto agility, because more and more crypto will get busted over the next 10 years or so. And if you've got a product that's going to be in the marketplace for 10 years or 15 years, the crypto is going to get busted. ISP development does not equal commercial development. I'll be frank. I mean, working at Microsoft on Windows and Office and SQL Server Exchange, Visual Studio, and so on, there's a lot of resources that we have at our disposal, and it's very, very different in the marketplace. Very, very different indeed. Different tools. A lot of stuff that I did historically was really low level C and C++ stuff. I go into the marketplace. I think in the last year, one customer does C and C++. The good thing is they were really happy to see me because they were sick of seeing web guys. They were. The last security professional that came on site with them was all ready to talk about SQL injection, cross-site scripting, cross-site request forgery, session stealing, JavaScript that, Java this, blah, blah, blah. They escorted the guy off the premises. It's like, no, C and C++, that's all we care about, embedded systems. And so I'm like, wow, that's a breath of fresh air for me. But yeah, different tools, different languages, totally different constraints. Totally different constraints. So the Microsoft SDL, the classic Microsoft SDL, is great for large ISVs. It's wonderful for large ISVs. But it's not great for commercial and sort of government public sector development. That's why the simplified SDL is way better for those customers. The way I like to sum it up, 200-page document, 40-page document. Just giving you the core things that you need to focus on. Way more accessible, way more doable, and frankly, way more achievable. You can get some early runs on the board. Every customer I think I've spoken to over the last year or so, I've sort of walked away with 3 general recommendations. One, you got to get a baseline of level of expertise in here. Like the level is just not there. It's just not, and you're building these connected systems. You've got to. I'm not saying turn everyone into security experts. Just raise the bar. And here's some ideas for doing it. Next one, you got to tool up. Static analysis tools, dynamic analysis tools. A lot of people are doing really good code inspections and peer code reviews, but no one's running analysis tools. Now, I'm not saying analysis tools are a replacement for a good human being. They're not. However, they can find low-hanging fruit really, really rapidly, and they scale really well. They can also be used as just-in-time learning tools. It's like, I've told this story many times, but there's an API in Windows. I probably use this API like once every 3 years. It's create process. And I always forget that there's 2 arguments that go into create process, where the create process API actually dynamically allocates the memory for you. And it's up to the caller to free that memory. I always forget. Always. Every single time. Thankfully, at least twice a day, I always run my /analyze pass over my code, where /analyze will remind me that I haven't freed these 2 buffers. And I go and fix the code. But so it's like a just-in-time learning tool. Learn some of these things. And it's really good for learning issues that you weren't necessarily aware of. So the results that you get from analysis tools are great learning experiences as well. So for large ISVs, SDL works really, really well. And I've worked with a number of very large ISVs on the SDL. But for smaller corporations, smaller outfits who are not building large-scale commercial, ISV, the Adobes and the Sun, Oracles, IBMs, Microsofts of the world, the simplified SDL is perfect. Works really, really well. It's very digestible and very easy to implement. So my summary of sorts, quickly go through it and then I'll wrap it up. Security expertise is like nil. Again, when Jeremiah and I were speaking yesterday, his contention, and I kind of agree with it too, is that things may actually be getting worse because there's more and more developers coming into the marketplace to fill that void, but they're not getting trained. They don't know the basics of this stuff. And so they're producing a whole bunch of junk rapidly. And so in essence, the quality is going down, the security quality is going down. People are just not learning from their mistakes. You've got to log bugs, you've got to find trends. You can only find trends if you log bugs correctly. And when I say that, I mean, don't log a bug that says, it doesn't work. I mean, what did you do? What did you see? Did it crash? What does the debugger say? I mean, things like this, that really help out. All bugs are not created equal. This is really a lesson for security professionals. Pick your battles. All bugs are not created equal. If you go in full charge saying we're going to fix every single security vulnerability, regardless of its severity, you will lose so much credibility that when it comes to really get one that you really need to fix, no one will listen to you. It's the boy who cried wolf. It's a classic example of that. We need more threat models. If you're not building threat models, you've got to start building threat models. We find design issue after design issue every single time when we build threat models. Defining secure just helps understand that you don't need to be perfect, but sometimes you may need to fail fast or fail closed. It's all about, we're finding now it's more moving to privacy. It's not just security anymore. It's privacy of data. A lot of these memory corruption defenses that we have in the OSs and these sandboxing capabilities are not about reducing access to data. It's all about protecting the system from being compromised and maintaining the integrity of the OS. SQL injections are everywhere. People are going to start focusing more and more on this. A system as secure as the weakest link is just not true. You can do things like encrypting data and other compensating controls. People just don't get crypto. They just don't. And then lastly, one thing that has been a real painful learning for me is that ISV application development is not the same as sort of the commercial world. It's totally different. Different languages, different tool sets, different skills, different requirements, different constraints. I mean, just about nothing's the same, really. So with that, I'm a little over, so I probably can't take any questions. So if you have any questions, I'll be milling around for a little bit. Any comments, questions, please come up and talk to me. And there's my email address if you want to email me with any follow-up questions. And I appreciate your time. Thank you very much.